In this video, I will talk about correlation versus causation. These are concepts that I'm sure you've heard before. I'll try to dive a bit deeper into them here in this video. So, idea is to get a sense of what do these concepts mean and how are they different, but also talking about what does it actually mean for something to cause something else, and should we even think of single or multiple causes, and what is a cause in the end. The meaning of the phrase is that we often claim that something causes something else. So the meaning can be sort of instantiated in many different ways. We can say something leads to or brings about or harms, impact, reduces something, increases something else or decreases something. So we use it often in everyday language and say that something causes something else. And this is what we'll want to get a sense of. And this will then lead into part 2 of this lecture, where we will dive into the golden standard for establishing causality, which is experiments or randomized controlled trials. The same thing. Okay, so we have this idea, and I think we have this notion that we know that correlation does not equal causation. Just because some things are correlated does not mean that they are sort of causally linked to each other. So this Tyler Vision page has a bunch of examples of weird stuff that is just extremely highly correlated. So the consumption of margarine is 99% correlated with divorce rates in Maine. And it's not like people get divorced because they consume too much margarine or the other way around. There are a bunch of other examples. It's just because there is so much data in the world that in the end a bunch of stuff will be linked. What we want to get a sense of is when can we be certain that there is a causal relation, because what is happening in the human mind, and we'll get back to this in lesson 8 when we talk about Kahneman's text, is that we as human beings have a tendency to see stuff being linked in a causal way. That's how we make sense of the world. We link things, and that's why we sometimes end up linking things that shouldn't be linked, because we have this natural tendency of linking two different things together. In this case, with margarine and divorce rates, it's probably so obvious that we shouldn't be too worried about it, but there are other more sophisticated and more subtle situations that we'll try to address where this is not so straightforward. But again, we are after the causal effect. So sun can cause more consumption of ice cream. It can also cause people to get sunburned. But of course, sunburn doesn't cause more ice cream to be eaten, or ice cream, an increase in the consumption of ice cream doesn't cause more sunburns. But these things are correlated. The more ice cream that is being eaten in Denmark, it's correlated with how much of a sunburn that individuals are getting. But again, this is because of another causal factor, and that's really a key thing that we'll try to get a sense of here, is that we need to be sure in the way that we design our research that we can be certain that it's the actual causal factor that we've gotten a hold of, and not some more sort of spurious correlation where something is correlated but it's because of another factor. And you can maybe put the video on pause and just reread this piece of text. It's from the Barrowman, from the curriculum. I want to sort of highlight the essence of it, because it illustrates how we can sometimes identify something that clearly seems to be related to the effect, but actually might be sort of hiding another underlying causal factor. Okay, so this is a very famous example of a psychologist, Gottman, who interviewed married couples. And based on these interviews, based on these conversations he had with these married couples, he apparently had a 94% success rate in terms of predicting whether these couples would get divorced within 3 years. So calling it a success rate and a prediction might be sort of a little bit off. But he was very good based on these conversations, because he could identify how much contempt and criticism and how defensive they were when they talked to each other, these married couples. He could then use that as an information to get to his prediction. But this is then often, as Barrowman points out, often been misinterpreted, because it's not like you could then divorce-proof your marriage and change the way you communicate and then make sure you don't get divorced. Because the issue is that these factors of communication are not necessarily the causal factors that create the divorce. It could often be the case that it was actually another underlying factor, whatever that could be, of disagreements or unhappiness, that caused the poor communication and also caused the divorce. It's basically the same thing as we saw with the ice cream example, that these two are strongly correlated, but in the end there is another causal factor that is causing both of them. So the point here is that we can't be sure that the outcome is due to these communicative behaviors, and we certainly can't be sure that changing these communicative behaviors would actually change the outcome. And it turns out that GodMed actually wasn't that successful in sort of making sure that people didn't get divorced. So again, what we are after is that we want to create a research design where we're sure that we've identified an actual causal effect and not what we can call a confounder. Confounder is where something is sort of interacting or mixing something up, and in this case it could be that the communicative patterns are not the actual underlying cause, but they sort of confound, they confuse our interpretation of what is actually going on. So this is something that we want to learn using our insights into research design that we will be generating to become better at making sure that there is this causal effect that we're after. Another challenge that we already heard about in lecture 1 is this thing about selection. We have to be sure that what we're seeing as a sort of a causal effect is not just because we see a biased selection of data. It's not because we only see part of the data, we only look at the successful entrepreneurs or only look at the planes that actually get home in the Second World War, that then leads us to a certain kind of conclusion, for instance, of how to become a successful entrepreneur. So that can often then also be an issue, that it's because we only look at a subset of the data that we can end up thinking something is causally related, even though that it's not. We might end up concluding that all successful entrepreneurs sleep at least 5 hours per night, but the unsuccessful entrepreneurs probably also sleep 5 hours per night. So it's not really an actual causal relation in a meaningful sense. And the reason why all these things about causality is really important is highlighted in this slide, which I'll try to really go through in detail because it's quite important. The reason is that scientists, and especially the media, has a tendency to oversell a certain story. Okay, so what are we looking at here? On sort of this, you could call it the x-axis from left to right, we have a categorization of a strength of causal inference. How certain can we be that what we've identified is not just a correlation, but it's actually a causal relation? As you can see, this is not sort of either it's true or not true. It's sort of a continuum. To the left, there are lots of problems with the research design, and we can't be certain that this is actually causality. The more we're to the right, we can say, okay, this is very, very likely that we've identified a causal effect. What we see when we look at the academic studies, and this is then the group of researchers who've looked at the 50 studies published in this journal +1 that have been shared the most on social media. So they found the 50 studies that have been shared in total 1.3 million times. So these have really been shared a lot. These have been read by many people. They've looked at these 50 studies, and then a group of experts have rated these studies and assessed, well, what's the strengths of the causal inferences that these studies could make. As you can see, only 4%, only 2 of them were really in this very high category. 1 was in the high category, but a big bulk of them were in sort of the low or the moderate categories. Meaning there were certain kind of problems in the research design that meant that we can't be 100% sure they've identified an actual causal effect. If we look at the studies themselves, well, what causal language do they use in these 50+1 articles? So what language does the authors themselves use? The first row is outside experts that have recategorized what this research design and the studies actually could do. The next layer here is the researchers themselves who've authored these 50 studies, how they categorize it. And as you can see, we've suddenly moved from 4% and this very high causal, we have identified a causal effect, to 20%. So 5 times as many are certain that they've actually identified a causal effect. And as you can see, they are more certain about causality than the outside experts. Okay, so who knows, maybe the authors are actually right. This is also to some degree a subjective assessment. But when we then see, and this is really the key point, when we then see the media studies, suddenly 44% of all media, sort of like newspaper articles about these 50 papers, almost half of them use a language is caused by, is due to. More coffee drinking leads to higher whatever, or eating more chocolate leads to higher whatever it could be. They have identified, they claim that they sort of portrayed as a causal effect, even though the original studies actually didn't try to do it themselves, or certainly shouldn't have done it themselves. So it's a fundamental challenge that we see both in scientific studies, but in particular in the media stories, in newspaper articles about scientific studies, that they tend to oversell how certain we can be about the conclusion in this research. And this is then also why I think it's a fundamentally important competence to have, to be able to read a newspaper article and say, well, not just be skeptical, we can all be skeptical, but be skeptical in an informed way where we can say, well, because the data has been collected in this way, I actually can figure out that we should not trust this particular conclusion because for various X, Y, Z reason, whatever happens in the particular context, we cannot be certain of it. And we'll see a lot of examples of that, both in the next lesson on experiments, but also research design in general. We'll be getting the tools to become much better at identifying how much we should trust the results of a given study. And this is even if we don't know the theory that is involved, we don't have to be field experts. There are some sort of fundamental things about research design that we can pay attention to. So that's sort of the challenge. This is basically just to identify the challenge that we have and showing that this is a challenge in newspaper articles. And what we want to get is the tools to be better at this. But I also want to sort of say a few more words about what does this causation then mean? Okay, we know that it means enhance or impact or leads to or has the consequence, or all these other sort of everyday terms we can use. But is it actually the true causal effect? And I've sort of already indicated that no, I mean, this tweet really highlights it or summarizes it. Causality is not binary. We should not think of causality as either being there or not. Our causal explanation can have various kinds of certainty. So it's a continuum, like we see here. It's a continuum of being very uncertain to being very certain about the truth of a causal effect. And so while we in the theory of gravity could say, well, it's really deterministic, in our field it's very much probabilistic. So the impact of incentives on solving simple tasks is fairly high, but it's certainly not a one-to-one match. So that's a key thing in social sciences. We should think of causality as being likely. In addition to that, we should also think of, well, it's not only a question of whether it's sort of a one-to-one deterministic match or whether it's just probabilities, but should we maybe often think of multiple causal effects? As the word cause might make us think of that there is just one thing. One thing causes something else. Sunshine causes sunburn. But as even John Stuart Mill said quite a while ago, it's rare that there is a single antecedent. It's rare that there's a single thing that comes before the consequence. There's usually a sum of several things that need to be in place for an effect to happen. So often we shouldn't think of one cause. Yes, smoking has a big impact on lung cancer, but there are a number of other factors that can either decrease or even completely eliminate the potential impact of smoking. And even such a simple question as, does lightning cause fire, actually illustrates this, because yes, I guess in some sense it does. You can see a situation where there is a lightning strike and a fire emerges. But, I mean, is the dry ground? What's the temperature? Has it rained? Are there other random factors that play a role? It's not sort of lightning as a single factor that will always sort of be the sole reason for why something is likely to, why a fire might emerge. There are often multiple causes for something to happen. And organizational success is not depending on one single factor, it is depending on a long range of various different factors. And as also already emphasized, it's not just a matter of probabilities, it's not just a matter of that causes are often coming from multiple places. It's also an average causal effect that we're usually dealing with in social science. So just because there are some humans that don't respond to a cause in the same way as others, I mean, that's just the way life is, and it's something we'll also dive deeper into. We still think that there generally is a causal effect, even though not everyone benefits from a certain kind of drug, as the medicine slide illustrated the last time. And then also just a sort of very basic philosophical question of whether causal effects are even real, because we can't really see them. Well, we might be able to see this, feel the sunshine that could sort of create the sunburn, but it's not like we can really dig down into the skin just with our bare eyes and see the actual causal effect, or how financial incentives influences human behavior. Again, we know what a financial incentive is and we can look at the performance, but There is something in between here that is sort of difficult to completely specify what it is, this causation. And it's something that we'll get back to in several other lessons. To what degree causation is a feature of the physical world or just a convenient way to think about relationships. So overall, and that's really also then the key message here is, yes, correlation does not imply causation. Correlation does not imply causation, but it's evidence for causation. So we should sort of be cautious about this. It's often said correlation does not imply correlation, as if correlation does not imply causation, as if, I mean, we don't have any evidence for it. Well, the word imply is really meant to mean something strong here, because correlation certainly indicates causation, as also written in the Barrowman article. It doesn't imply causation, but it does waggle its eyebrow suggestively and gesture furtively, while mouthing, look over there. So if there is a correlation, it's certainly worth looking into. Maybe we find out that there wasn't any relation, but it's certainly something to pay attention to. So we shouldn't really say it doesn't imply causation to make it sound like that there's no relation at all. If there is a correlation, there's a good chance that there might be some causal factor associated with it. But the aim is to reduce uncertainty. The aim is to figure out how can we be more certain about the conclusions that we come up with in science. So science operates as a procedure of uncertainty reduction, as we'll hear more about in lesson 10. So it's not truth in the sort of complete capital T kind of way, but something similar to it that we often have to settle with, that we get to. But the question then still is, how can we be sure that X actually causes Y? Let's take an example. Let's assume that out of 1,000 firms, 500 have decided to increase salary in 17, and the other 500 did not. Firms where salary was increased, they actually had a higher productivity in 18. Let's say this is how the correlation looks like. Can we be certain that the salary increase actually led to this higher productivity? Well, apparently the 500 firms in this hypothetical example just decided to increase their salary. But why have these particular companies increased the salary? Why have these firms selected into the salary increase? Maybe because they knew they were going to do well in 2018 and they wanted to be sure to keep their employees, or they could afford to keep their employees. So maybe it's actually just because they knew they were going to do well that they decided to preemptively raise the salary to keep their key employees. Maybe it's just better economic conditions in a particular industry that sort of have led these to a higher demand and then could facilitate higher productivity. Or maybe it's not the salary increase, maybe it's something else, recognition or new leadership, that influenced behavior in these particular 500 firms. So maybe it's the new leaders that decided to increase salary that then also decided to do something else. So the thing is that with many kinds of situations like these, where it really appears to be, it would be meaningful if the salary increase led to higher productivity. But again, we want to be really sure that it was this particular factor and not some other factor that we're not just paying attention to. So how can we be really sure? It's the randomized control trial. It provides what we call a counterfactual, as Barrowman talks about on page 11 and 12. So we have the medicine example. We have a group of patients. Some receive the drug and some don't receive the drug. And this way we can not only say, let's take 100 people, we give them all a headache pill and then see how many don't have headache afterwards. That could lead to the conclusion that a headache pill is really, really effective, because over time almost everyone loses their headache. But what we want to do is to compare in a given period of time 50 people that get the headache pill and 50 people that don't. We want the counterfactual. We want to know what would have happened to Group B if Group B had received Group A's treatment. And this is then what we then want to look into with the randomized control trial. We want to find out how the randomized control trial, how an experiment can give us this almost certainty that it's the headache pill, it's the intervention, it's the salary increase, or whatever the example is, that led to the causal effect. So how is it that we should design such a trial in order to be sure about causality? So that's the aim of the next session, is to get this understanding of randomized control trials. The aim of this one was to say, look, let's get a good sense of the concept of correlation causation. What are some of the challenges of why sometimes something might appear to be causally related? Why might it? Because there are other underlying factors or because of selection effects. And we also then went through, well, what does it mean for something to, what does it mean to say that something is a causal effect? Should we think of as single or multi-causes? And in social science, we should sort of settle with probabilistic causes that have an average effect. Sort of some general insights into what it means when we were looking for causality. And then we're getting some insight into how to actually do that in the next videos and sessions.